This time I want to do troubleshoot combustion problems with you. So these are a big deal that they can be on your AP test even as a multiple choice question, and you're going to have one of these on your Chapter 3 test. So we need to know how to turn a combustion analysis into an empirical formula problem using mass percents. So what do we have? This is an empirical formula problem, essentially in its heart. So what you have is we need to figure out how many grams of each of these chemicals we have: carbon, hydrogen, and oxygen. Typically, we're also given a total grams of the sample. And we've got this unknown sample that we're trying to analyze. In an empirical formula problem, we start with percentages, so we can get here really easily. In a combustion problem, we don't. We have to use some lab techniques to get to these percentages. So when you burn a sample, what you're doing is, with conservation of mass, you're taking all the carbon and you're turning it into carbon dioxide. So if you know how much of that carbon is in carbon dioxide, then you can figure out how much carbon you have in the sample, and you can do a quick empirical formula. We also take all of the hydrogen in the unknown and turn it into water. So it's a 100% conservation of matter, and therefore, if we can figure out, here's our grams of carbon, if we can figure out how many grams of hydrogen are in the water, then we know how many grams of hydrogen were originally in this sample, because it all got turned into water. So the question is, how do we get these two numbers so that we can come over here and do an empirical formula problem? Now the trick is you can't actually keep track of the oxygen that way. Oxygen is in the CO2, it's in the water, and there's usually excess oxygen in order to make sure everything burns. So you can't actually do this with the water, but we can do this with the carbon and the hydrogen. How do we get the oxygen then? Well, remember down here we have a total sample. If this total sample was 5 grams, and we came out and we said 3 grams were carbon and 1 gram was hydrogen, we could get 1 gram of oxygen by subtracting, because we still have conservation of matter over here to figure out that oxygen. So we can do this quick subtraction from a total to get that. Now those numbers won't work, I just made them up, but kind of that's the idea. So how do we get the percent or the grams of carbon and the grams of hydrogen over here? That's where mass percents come in. Okay, we know how much of carbon is in CO2 because it is a fixed proportion. So this is where we have to think in ratios, and mass ratios work here. So for every carbon dioxide, there will be 12.01 grams of carbon in every 44.01 grams of CO2. Okay, what that does is that tells us a certain percentage, I think it's like 27%, 0.27. That tells us that whatever sample size of the carbon dioxide we have, this proportion of it is going to be the grams of carbon. So this is a way where we can just it's really the only gram to gram conversion we can do because it's within the molecule itself. I can say 44 grams of carbon dioxide does contain 12 grams of carbon. So we can do a quick conversion that way using that proportion. We can do the same thing with water. If we know the sample size of water, we can say how much of it is hydrogen. Well, there are 2 hydrogens here. So the molar mass of water is 18.02 grams of water. And since there's 2 hydrogens, we're going to say 2.02 grams of hydrogen is in the water. So that's our conversion or our proportion for the hydrogen. So going back then, if we know how much CO2 we have, we can use this to figure out how much carbon we have. And then if we know how much water we had in the combustion, we can know how much hydrogen we have. Then, that's the combustion side. You take these numbers over here, and then you're left with a pretty simple empirical formula problem. So this is combustion analysis. It can go really quick once you understand the construct, but you've got some conservation of mass ideas over here. and then you've got some conservation of mass ideas over here. Okay. Now, it doesn't have to be oxygen. There's a lot of weird problems. This other substance here could be nitrogen. It could be iron. It could be lots of other things. But we just change that down here. It doesn't change the carbon-hydrogen portion of this. This still stays the same. You just get other strange chemicals over here, but they will still add up to a total sample size. So we can still do combustion analysis with other chemicals, okay? So hopefully that helps you out with combustion analysis, and there's a quick recap troubleshooting that type of problem.